is it actually lends itself to really pretty demos. So what I've been doing is I challenged myself with producing a really sort of visually impressive demo to show what is actually happening under the covers with kNative. So very quickly, for those who don't know what kNative actually is, kNative is technically called serverless, but I don't know about you, I hate the term serverless because it's just someone else's server or someone else's compute. And what it actually allows you to do is to, in its most simplest form, scale an app running in a pod on OpenShift down to 0 copies. And that's all it does. And the reason it does that, and the reason this is really, really, really cool from an OpenShift perspective is that, let's say you're running 10 microservices or 10 web services in 10 separate pods. And now those pods, the service is called once every 24 hours. And in the other pod, it's called once every 3 seconds. Now, if you want to actually stand those up as services on OpenShift or Kubernetes, they have to be resident. They have to be an existing pod to service the actual requests. So what you end up with effectively is 9 services that exist all the time when they're called once every 24 hours. So that's 10 pods running for an entire 24-hour duration, of which 9 of them are only called once every 24 hours. So it's not efficient. Pods and images and containers themselves are incredibly efficient. So we want to make OpenShift very efficient. So what this kNative technology allows you to do is to actually register an application as being a kNative service. And at that point, what happens is OpenShift will spin it down to 0 and only spin it up when it's called. And when it's called, there's a timeout on the actual calls. So when it hasn't been called for a certain amount of time, it'll then spin down to 0 again. So this is pretty cool functionality. And the actual operator you install on OpenShift 4.6 gives you kNative serving via something called kNative serving and kNative eventing. Eventing is that the event that drives the creation of the pod is actually off of a Kafka stream. So you actually put a message on a Kafka stream, and that arrival within the event itself will cause the pod to spin up and actually process the request. kNative serving is actually based on ingress via serving. So when someone calls the fully qualified domain name, which is the endpoint into the application itself, it gets spun up. So what I wanted to do was actually, number one, I wanted to really stress the OpenShift system. To give it something fun to do and see if I could actually break it, because that's what I tend to do with every OpenShift system I'm given. And secondly, I wanted to do something that was a little bit more visually attractive. So what I've done is I've actually produced a demo, and this is all available on GitHub, and I'm going to show you it running. I'll show you the source code. I'll show you how it actually sits and how it sort of starts up and all those kind of things. But what it does is it generates a virtual Loom. And what that Loom is basically it's a set of coloured columns, and each row in the actual Loom itself has 4 random colours. These colours are served from web services. They're actually node applications. And the node application just sits there and basically returns you a colour. But how the application works is you override the colour with an event variable. So you can have an environment variable which actually defines the colour it should return. So what I've done is I've spun up 4 versions of 4 copies of the app. So there are 4 copies of the app, each returning a color, and there are 3 revisions returning different colors themselves. So every time you call a single one, you get 1 of 3 colors, and you've got the actual interface itself randomly calls 1 of the 4 microservices. This may not sound like it's making sense. So what I'll rather do is I'll share my screen a second, assuming that screen sharing works. And tell me if you can see this. That work?
Yep.
Yeah. For a change, it works.
That's the advantage of working for Red Hat and having a Mac.
Oh.
Sorry. Yeah. So what I've actually got, I'll show you the user interface first. So I've got an application called a namespace called Chain Test, in which I'm running 4 kNative services, each of which has 3 revisions. You can see at the moment there's nothing running. There's no pods active whatsoever. I've also got effectively another namespace which is running a web app, which I'll show you very quickly if I go into demo test. It's a very simple web app. It's a Node app. And just to show you that it's simple, I'll show you what it's actually doing. If I go into the terminal, go into the logs. You can see it's a very simple Node app, it's just waiting on 8080. I said the source code is available for this. If I go back to the chain test, you can see from the topology, it's currently running what we call four kNative services. Each of the services has 3 revisions. So within the service itself, there's traffic balancing, which you can set or set yourself. So what happens is, when the fully qualified domain name is called for each of the services, it will pass it off to each of the 3 revisions inside based on the traffic percentages. So for example, the top one, the K service in this display is actually link 3. 40% of the traffic is going to go to revision 3, 30% is going to go to revision 2, and 30% is going to go to revision 1. Now I'll show you, before I actually start running it, I want to show you the source code, because it's very interesting in the way it actually does it. So if I go and look at the scripts, I've got a setup script I run. What the setup script does is, assuming you've installed kNative serving, which is simply a case of adding the operator into 4.6, you simply run this script. And you can see what it's doing. The first thing it's doing is it's creating a project called chain test. It's then manually creating the image streams and the build configs. So what it does is it creates an image stream for each of the actual builds it wants to do, and then runs the build configs that actually physically build those applications. When it's finished the build itself, it then actually pushes some YAML in which creates the kNative services. So what I want to show you is, if I go to the actual YAML to show you what it looks like, it is, although I'm talking quickly, it is reasonably simple to do this. So for the image streams themselves, for example, the link 1 image stream, you can see it's very, very simple. Metadata name equals link 1, lookup policy equals false. Look at the build config for link 1, so link 1 build config. You can see it's a very, very simple one. It's using the universal the UBI 7 Node.js source to image, and it's building it from an actual subdirectory in the GitHub repo for link 1. That's the simple stuff, the image stream and the build configs. If we go and look at the kNative services, this is where it gets interesting. This is the way I'm defining the kNative service. Now, the one thing I don't like about this, because I'm going to be honest, is that I wish they didn't call it service, because we've already got a service object in the namespaces, which refers to the ingress point for the applications. But I spent a lot of time doing OC get service and not seeing anything when I was trying to look at the kNative services. So anyway, it's called a service. Name is link 1. This one uses a container I've built. So that image stream and the build config does a source to image operation and builds that application in an image. The kNative service actually uses that image. And then what it does, you can see it's got success rate on 1, timeout seconds equals 10. The timeout seconds equals 10 is the interesting one. This is where I had some problems, because when you actually create a service from default using the user interface or using the command line, so there's a command line called kn which does all the service stuff, it defaults to 15 seconds timeout. And you can't change it as part of the creation process. And what makes that difficult is, when you create a kNative service, if you actually change any aspect of it, such as the timeout period, it creates a new revision. So what I had to do was manually create these revisions from scratch that were actually timing out at 10 seconds. I'll explain why. So the Loom itself actually does 4 calls per column, per row, into these microservices. It randomly picks one of those 4 microservices, randomly picks them 4 times and calls into them. There's a 15-second timeout on the Loom. So each of those rows is actually built once every 15 seconds. But I've set the timeout on the kNative services to 10 seconds. So what I wanted to show is that actually when I'm running this thing, which calls it every 15 seconds, it's spinning up and spinning down those pods very, very quickly as a process of removing it from the kNative service. So if we go back to the topology itself, see I'm running 4 services. I'm going to start the Loom just to show you it running. I say all this is downloadable if you want to play with it yourself. But what it actually will do now is it will start 4 requests going off to the servers. If we go back to the actual kNative services, you'll see them start to spin up. And you won't see 4 services spinning up, because what it does is it randomly picks 4. So in this case, what it's probably done is it's called one of them twice, called the other one twice. If we go back to the demo page, should see a return point at this point. 2 have come back, 2 are currently loading. It records the average response time and the fastest response time as well to see what it's doing. So it's generated a set of 4 colors for the first one. It then waits 15 seconds and sets off the second one. If we go back to the topology, you can see that some of them are starting to spin down and some of them are starting to spin up again. And what this is showing you is actually when a request comes in, the application is spinning up, responding to that application request. when the request is physically timed out and the 10 seconds have expired, the actual kNative service is then spun down. So I'm probably not explaining it very well, but the reason I did this is I wanted to show people, notably customers or users or developers, the mechanisms by which OpenShift does it. So what you're seeing there is basically the little timers in the background actually shooting them down. If you watch them, the actual rings themselves will go dark blue when the things are actually expiring. Some of them won't expire because that 10 seconds is actually 10 seconds after the request has been removed. So it's not actually 10 seconds. It's 10 seconds plus a delta. And that delta can often be intercepted by another request coming in. But what I'll show you to actually show it in action is, if I go back to the Loom page, which is still doing its thing, I'll let this one load because I have OCD if it doesn't finish it. When it's loaded, I'm going to pause the Loom. So what that's done is it's stopped the requests coming in from the web page itself. And what you'll see if you watch it is the actual kNative services will actually start to time out and scale themselves down to 0. And the beautiful thing about this is when you're running this in the namespace itself, once these have all scaled down to 0, there's nothing running. The actual sort of hooks, the web hooks and the response hooks for actually generating a kNative service based on the service request are actually part of the operator. So they're not actually part of your application itself. So once this is finished, once they've actually timed out and they start to spin down and we go down to the situation where there are no pods running, I've got 0 footprint in that namespace. Now what's really cool about that is that let's say you've got 4 or 5 nodes where you're running the OpenShift instance. You get much more space to do other things. You don't have those resident services that are waiting for those requests that are coming in once every 24 hours. So by using kNative, which you can apply to any of the actual containers that can be supported within the OpenShift system, you've got ability to actually serve a lot more than you should be able to. So you can reduce the number of nodes you're running, reduce the size of your OpenShift instances yourself, and yet still offer a lot more in terms of numbers of the services that can be responded to. So you can see now it's actually scaled right down to 0 again. And if I go to my command line a second, if you bear with me. If there's any questions, feel free to jump in. If I do OC project, see what I'm in. So I'll spell project right. I'm currently in chain test. If I do OC get pods, you can see when it comes back, it's only got 4 pods. And those 4 pods are completed pods. They're the pods that were actually used to do the builds at the start of the process. It's not actually running any pods. So the footprint of this namespace is really, really small at the moment because those completed pods are actually just metadata. They're not actually physical pods. Kick the Loom back up again. Start the Loom. And we should see the thing start to spin up again as the requests come in. What I'd like from this, I mean, we're not. It's very lucky for us in Red Hat that we actually talk to the people that build this kind of stuff. But I'd like to see some traffic indication on this page to see where the actual requests are coming in on the traffic, because we can dynamically actually display the pods coming up and coming down. But I'd also like to see the requests hitting the edges of the pods. But if I go back and do an OC get pods now, actually see the pods actually coming up and actually being created and running. So that was kind of the whole point of this demonstration, was to show the dynamic nature of the kNative stuff. Very quickly on the kNative stuff itself, the kn stuff, we've got a command line called kn. And kn is basically the way to interact with the services. So you can do things like kn service list, to list all the services that are currently defined within that namespace, because it's namespace specific. It's also got routes, and that's something interesting I'll talk about in a second. So that's the actual fully qualified domain names by which you get into the system. On a normal OpenShift system, when you create an application, you get a route. I'll show you this. If I go to the actual demo test, the demo that's serving the Loom itself, if I then go to the administrator side and look at the networking for this, you'll find I've got a route. And what I was surprised about is that when I was looking at the kNative side, no routes. There's no fully qualified domain names defined as routes applying to the kNative services. And that really confused me at first, because how is someone getting into this? And what it is the kNative operator itself, the thing that runs the kNative services. You can't have routes for those, because routes have to tie to an existing service. They have to have a response point within the OpenShift cluster. So what the operator does, it stands up effectively a proxy set of routes using a technology called Courier. So there are routes, but those routes are only applicable to the kNative services. So when that route actually terminates at the edge point within OpenShift, the traffic goes into the kNative operator, which then routes it via courier to the services. And what the kNative operator does is it looks for the existence of the pods themselves. And if the pods haven't been spun up, it'll spin up a pod. And that's the reason that caught me out, the fact that there were no routes into the actual services themselves. But again, if you go back to the actual command line, that's what the kn root stuff does. It gives me a list of the routes. The other one that's nice, if I look at revisions. So a revision is an individual instance of the service. And you can have multiple revisions per kNative service. If I do a list on this, you'll see I've actually got 12 revisions. And those 12 endpoints I told you about, those match effectively the 12, if we go back to the topology page on developer, they match those 12 pods. So those 12 revisions match the pods themselves. And that's the way that it actually pins it together. But I tend to get excited about this because, number one, it's a dynamic technology. And number two, I can see a really good use for this if you want to make things efficient. Now, one last thing I want to show you before I open it up for questions or just stunned silence is if we look at the developer console for this, look at the network side. I'll leave it running for a bit whilst the Loom is running. You can tell instantly from the network response as to whether or not it's pinging into an existing pod, an existing revision, or spinning up another revision, because the difference is milliseconds to seconds. It's like 3 seconds response time when it's actually spinning it up. Now, you can improve that. You can make that much faster. We got this technology called Quarkus, which is super fast Java. It has supersonic subatomic Java, it's called. And you can actually write response points or, for example, RESTful services with a Quarkus engine, with a Quarkus native engine, and get that response speed, the spin-up speed, into the microseconds. So there's an opportunity here to make your OpenShift instances not only massively efficient, but massively responsive. And also there's pretty colors. I was going to do it with sounds, but that would just drive people insane. I was going to make it so the demo would allow you to change the recurrence period and the timeout period of the revisions themselves. So you could have a Loom that was running very, very, very quickly or very, very slowly. But again, I say if anyone's interested, it's available on a GitHub repo to have a play with. That's that one there. It's on Uther P0/kNative chain. And I just wanted to produce something that was slightly more visual than normal in terms of demos. So does that make sense? Is that a reasonably good demo, or was that something that just is a bit too showy?
I like that. I think you touched on one of the key questions that I would have had about kNative regarding its ability to respond while there's no pods running behind any service, so that you can truly spin your worker environment down to essentially zero resource utilization within the scope of a certain project, while still allowing it to be responsive when traffic picks up again. It's a good solution, and it opens up, the mind for inspiration to look for ways to implement it. So thank you for going over that.
Yeah, no problems.
It's funny, right, that it's called serverless, because I would kind of fight about the name as well, because it's not really serverless, right? It's just better server utilization, really, when we're honest about it. Because it's not like Lambdas where it doesn't require any infrastructure underneath, because we still need the infrastructure. We just utilize it better by shutting things off that we don't need.
Absolutely, absolutely. And we've actually got another piece of functionality coming very, very soon, based on something called Boson, which I've been looking at, and that's functions as part of kNative. So at the moment, when you're using kNative, you're using images. So you have to define an image for the service itself, and you spin up that image. We're also tending slightly into the Lambda side with functions, and what functions allow you to do is to define functional endpoints that we actually stand up via kNative, but they're shared across multiple namespaces. So we are looking at the Lambda stuff, but I agree with you entirely on the name serverless. It always makes me laugh because I tend to talk to customers and say, serverless for me equates to unicorn's arse because it's coming from somewhere. It's not magic. There is something behind this. Cloud is someone else's computer. Serverless is someone else's compute.
It was good to see a deep dive into the mechanics of kNative, because obviously for my personal stake in something like this is to support serverless functions, right? Functions as a service. I've worked with, or I should say tested, haven't really been implemented in production, open functions as a service, which is a good way of solving the problem of how do you replicate Lambda type functionality in a Kubernetes control plane. However, looking at kNative, it wasn't 100% clear how it delivered a similar solution. But it's good to hear that it's going to be diving into the concept of serverless functions as well. I hope that it can focus more on the concept of functions being idempotent. You call upon a function to get a result, and the same request will always deliver the same result. It's not a REST API. It's different. Depending on the type of application you're building, if you decompose it to the point where you have a core set of functions that deliver something, it could be customer information, where you have a customer ID and returns data on that customer, or something else that might be resource intensive on the back end. You want to make sure that you're getting consistent results and reducing the load when it's not necessary, but also you touched on the ability to spin back up and make it responsive with tools like Quarkus. If you're building with Java, you want to make sure your Java pod can start in just a few seconds rather than like a minute for like a JVM to start up. Those are all important. Nobody mentioned Go. Go is another option, but personally, I prefer to stick with something like Java, since I think most developers that I've worked with at the company, that I've interacted with, I should say, at least where we are primarily a Java shop, and .NET. And Quarkus is kind of a big deal for us. So Quarkus-backed Java implementations on kNative with certain functions as a service implementations, I could see as fulfilling some of our needs for the applications that we build, at least.
Yeah, it sounds good. I mean, one of the key aspects of the Bosun project is that we're going to support Quarkus and Node.js, I think, first of all, maybe Go as well. So you'll be able to define your functions as components within a Quarkus build. And what the func will actually do is build a Quarkus image behind the scenes and then keep it resident, but provide the same kind of kNative function accessibility of it. So it's kind of a more fine-grained way of doing kNative in the long term. I say it's brand new, so I'm not sure whether I'm allowed to talk about it, but it is on GitHub, so you can go and have a look at how far we've got with it. If you want to have a quick peek.
I have a question. I remember you mentioned, using kNative events and, having Kafka to help you spin up things. Could you dive a little deeper on that and how that
Yeah, I
works?
say it's one of the things I haven't really had a play with in anger, because my understanding was more around the serving perspective, but how it actually works, it's driven by the same operator. So I'll show you very quickly. If I go over here, if I log out of this one and log back in as, bear with me a second because my video page is over the log point. If I log out and then log back in as the cluster admin, show what the features are from that perspective. So we go and look at the operator. What I can do is I